Well, hey guys, how's it been going? This is JSer, who is not good at algorithms. Today I'm going to take attend this weekly contest 190. Let's start. Okay. 5416. Check if a word occurs as a prefix of any word in a sentence. What is that? Given a sentence that consists of some words separated by a single space. And a search word. Okay. I have to check if search word is a prefix of any word in sentence. Return the index of the word in sentence where search word is a prefix of this word. If search word is a prefix of more than one word, return the index of the first word. If there is no such word, return -1. A prefix of S is any leading contiguous substring of S. Well, we just do the matching, right? Well, okay, let's do it. Rather than we split into array, we could just we get the word index, right? 4. If we split, it will be actually, if it's a long string, we split is waste of time. Like if the first word is the search word, right? So I think we will just loop through the whole string and calculate the space count and match it. It's like, yeah. Let's do it. So idea is loop through the sentence. Okay, I'll stop writing the commands because the time matters for this score. Okay, for let I through the sentence. Okay, the word there will be separated by a single space. So there's no training space. We don't need to trim. Okay, I'll keep up the let space count 0. If it is a space, we update it, right? +1, and we need to reset. Okay. I need to let I wait a minute. Loop through it and let J. Okay, let J is 0, which is index of search word. Cool. So if it is space, we move it. We plus the space count, and space, of course, doesn't match any word. So we need to do what? We need to not only move to the next one, but reset J, right? Reset J to 0. If not space, it's a word. Then we compare this word and current index with the from the search word. And if sentence I equals to search word J, then we say we could move J a little further, right? And yeah, and if for the other case, if it's not, then I need to set J to 0 because we need to start over again. No, if it is not word, we need to move to the next space. We don't need to compare, right? But anyway, it doesn't matter. Anyway, the I will move forward. We just move extra J. It's okay. And finally, we will check if here. Okay, if when we update j, the j would be if j equals to search word appended, which means the j is matched. If word is matched, we return. We will see how many spaces are there, right? If this is one space and matched here, then it will be the index of 1. Fourth word, so based to index based on 1. So okay, return space count plus 1. If not match, return minus 1. Is this work? Does this work? Let's review our code once more for the input like this. The first main I and sentence J, and the search for what? Search for bird. Not match. We move I to next one. Space with +1. Set I to J, and then the next one L doesn't match. Doesn't match. Set I to 0. Doesn't match. Does not match. Match. J space +1. Eating, not match, not match, not match. If there's a B here, let's say there's a B here, and it's match, we move J further. And the next one is G, does not match, we set J to 0. And then we got here BRUG. BURG matched, and there were 3 spaces, so we return 4. I think this should, let's run the code. Finished. I love eating burger. Burger answer 1. Huh? What? Really? I love eating burger. Burger. Where's the problem? Sentence I is if it's space. Oh shit. So this one should if this should return -1 also, like this. Use samples case. Wow, this is a new feature, I think. This one should return -1, right? Cool. Submit. Wrong answer. Shit. Yeah. Yeah. This must be a prefix of a new word, so it must be right after a space. And I'm so sad. This must be after a space, and we should not compare if it's not. If it's not, right? Okay, I'll keep another flag, which is very simple. Is from word start. At the beginning is true. Okay, when we made a space, then it is true. And if we made one, if it is from start, we will check this, right? If it is from word start, we compare the word, and it will fail if it does not match. So set to false. This should work, right? Yeah. Still wrong answer. Shit. Why? I'm not eating burger. This is the input. I love eating burger and burger. Huh? This is the original one. Okay. This from start true. Ah. If it's space, we do this. For the other words, we will check. Sad. Sad. Really. So sad. This is the easiest one, and I failed like 2 times. Oh, holy mother of God. Finally. This penalty time is very expensive. Okay, next one. Maximum number of vowels in a substring of given a string s and an integer k, return the maximum number of vowel letters in substring s with length k. Maximum number of vowel letters in any substring s with length k. What? Vowel letters is a, e, u, a, e, i, o, u, a, b, c, a string, k. So the substring of length k maximum has I vowel letter. So a, e, i, o, u for 2, it's already 2. So 2. So LeetCode, we got EET 2. I think these are very simple. We just use the sliding window and slide it from left to right, right? And then count it. Okay, so we use sliding window. Okay, we will move from left to right, and if it is more than the length become more than 3, we will move the previous one and add the next one. So first I'll set a vowel set. Vowel, how can I spell it? Vowel set. There's a new set. This is the vowel set, and then this k for let I 0. So let max 0. Let temp count, like no, vowel count current max vowel count. Okay, this is right. Count is 0. So we check it out. If s I is in the vowel set, which is has, then it's a vowel, right? We plus it, plus the account. And if length is more than k, need to remove the head. I mean, so for case 3, we will start at k3, right? So if I is bigger than or equal to k, we want to check the previous one, which is if vowel set has k I, this is I 3, 3 minus 3 0, so minus k, right? K numbers, k digits, this is k minus 1, k minus 2, and the next one is k minus 3. Cool. If it has it, then it's a vowel, right? It's a vowel. It's a vowel, so we need to subtract it with 1. So this is the right amount of vowels for the current substring. Well, we need to update the max equals math max current vowel count, and finally we will return the max. Return it. you need to short circuit faster. Say if it's already equals to k, then we should just return, or just okay, a break, maybe better. Break. Let's try run the code. I think this should work. This is easy one. Cool, we got 3. Let's try this. That's 4. It says it should be 1. I think this should work. Okay. Oh, this one is good. Let's go to the next one. Pseudo palindromatic paths in a binary tree. We're given a binary tree with node values are digits from 1 to 9. A path in the binary tree is said to be pseudo palindromic if at least one permutation of the node values in the path is a palindrome. Wow, I don't understand what it is. Return the number of pseudo palindromic paths from going from root node to leaf node. A path in the binary tree is said to be pseudo-palindromic if at least one permutation of the node values in the path is palindrome. What is? Like this tree, the figure above represents a given tree. There are 3 paths going from the root node. Here, here, here. The red path 2, 3, 3, the green path 2, 1, 1, 2, 3, 1. Among these paths, only red path and green path are pseudo-palindromic. Since the red path 2, 3, 3 can be rearranged to 3, 2, 3, 2, 3. The green, okay. For this, so what we return? We return output 2. How many paths? Okay. Oh, I see. The 2, 1, 1. Okay. 2, 1. No. 2, 1, 3, 1. No. For the path, it must be from the root, right? So the first problem, how can we determine? The first problem is how can we determine 2, 3, 3 could be palindrome, because any permutation is fine. If it is palindromic, then it must be symmetric. So like 1, 1, 2, 2. So every number must be at the amount of 2, except the middle one. If it is R, right? So if the length is even, we could say count the numbers to the count of all the numbers should be 2. If it is odd, then only one number is even. So I think we could do that in linear time. So okay, now we're going to go to each path. Sure, we could use DFS and keep a track of the path in a global one. Like we go to 2 and we push 3, we got 3. It is a leaf node. We check the amount, the count, and then 2, 3, 1. Then pop 3 out, and go to 2, 3, 1, right? Yeah, and then we pop 3 out, or pop 1 out, and then we pop 3 out, and then we go to 2 and go to 3, 1, 1, 1 again. Okay, so it's like backtracking. And we will use DFS. I'll just stop using recursion. I'll keep Okay, I'll keep the values are from digits 1 to 9, right? Okay, so we could use array to do that. And then for each array, we will keep track of the count. Okay, so let's do it. We create a count array equals new array. Because it's 1 to 9, we say it's 1 to 9. We just use array 9 to field 0, because at the beginning there will be no numbers for any of the numbers. And then we will use DFS. We create a stack. We push root in. If root is empty, it might be a case of root empty, right? For edge cases. Root is it palindrome path? Oh, so it's not empty. Oh, cool. Cool. And so while stack is not empty, we pop it. And we check, we pop it, and now we handle it, right? No, we need to know if when we pop, if we push it, if we pop, we subtract. We push, if we get an element out of the stack, it means it might be just popped. So we will subtract the count with 1, and then we push it in. It means it's still in the path, right? So the stack actually will have the deepest like will contain a whole path in the stack. Cool. When we maybe we don't need to pop. Okay, we pop or pick. Okay, the node should be we pick stack length -1. Now the stack means the path. The path, if the node is in the stack, it means the count is already done. So if node left we get an element, pop it out, we push left in, we push right. Wait a minute, how should I do it? When we push, we should push this straight to the bottom. Yeah. This is not right. Like 2, we got 2, and we got 2, 3. We got 3, 1. So what we should do? Push 1 in and push 3, right? And then we process 3. It is actually a leaf node, and we would process it. Or we should push 3. And then check. I see. So it's not like that. We will push the whole path into the stack. So if we get to the node, if node has left, we need to continuously push into the stack. Continuous push all the nodes in the stack. So I'll create a separate function called push stack. It's just accept a node while node is not equal to null. Stack push node equals node left. Okay, we push stack node left. When we push it, we should update the counter array, right? So counter array node left val +1. Let me push it. Okay. Now, so we push it. Now there's no left, right? We have. Oh no. I got it wrong. Wait a second. I should not do the root here. I just call push stack root, and now all the paths to the bottom will be get. So there will be no left. What is the leaf node? Leaf node means there is no left and no right. Right? So okay, so we check the node. If the node left is already pushed into the stack, right? So if node has a right node, we will continuously push it into it. Push node right. When we push it, actually we need to update the counter array here. Node val +=0, right? Okay, so now 233 is already pushed. If there's no, like 211 is pushed, and then we need to process, right? If has right, we push. Now for the else, if there's no right, but it's still no left, right? No left and no right, we will treat this as a leaf node. Leaf node. For a leaf node, we will do what? We will pop it. Const the leaf stack pop up. We pop it, and okay, I'll just say pop stack. Because we need to update the account. 1. Oh, sorry. Return node. So we pop the stack. We pop the stack. Like for here, we pop 1 out, and we pop. Oh, no. If it's leaf node, we check here. Check if palindromic and we will create a function. Check is palindromic. Function is here. So how we do it? So we check for each, and if we met count of 2, continue. If we meet count of 1, we will count it. Their maximum will be 1, right? Yeah, so let count of 1, 0, let count of none 0 equals 0. So for let I count of, traverse through this, if count is equals to true, continue. No. If 0, we continue because there's no numbering that. If count equals to 1, we update count 1 plus 1. Count now 0 equals to 0. If count equals to 2, else count of none equals 0. So the others could be yeah, it's okay. If count 1, maximum will be 1 element. So if it's bigger than 1, we return false. At last, we will check if return. Okay, is palindromic equals if okay, cast if count of 0 is R number, if it's R, then the account 1 must be 1. If it is even, then it must be 0. So this is the palindromic. We return this. Now we can check, because we made a leaf node, and okay, it should be count result. Let result equal 0. Okay, I'll set it. I just do result here. If is palindromic, if it's palindromic, we update the result plus 1. So now we need to pop the stack, right? Pop stack, we will pop until, like for 1, we need to pop. Pop to what? Pop to the first node. Pop to the node where the next right tree has, right? So for 2, 1, 1, we pop it and find the next one. This one has the right node, so we push. And then we pop this tree. We pop. But this node has the right tree, so its previous one. So well, should we still continue popping? So we will go to for pop. we will pop until a node has different right tree, right subtree. So we said we pop the first one. Okay, this is the pop the first one. We update the count array, and what we will do, we will say if the stack .name -1, if this node does not have right, if this has not right node, and or it has right node. Oh, maybe the stack doesn't. Maybe this stack there's no node, right? So if there is a node in this stack, until we met that, we will keep popping, right? While there is an element and it doesn't have the right node, or the right node it's equal to our node, yeah, if there's an element and it doesn't have a right node, or the right node it's currently popped, we will pop it. So we set node equals stack pop. Okay, I think we could just for this leaf node, it has no right, so this condition actually matches. I'll set, we create a node, yeah, and node equals stack to pop. We update the count array. Well, I don't think I'm doing it very concisely. -1 and node. Oh yeah, this is right. Just update. We pop it and we update to -1. And then finally, we return the result. Let's try. Run the code. 2 3 3 1 2 3 3 2 3 1 2 3 1. Use example case 2 3 1 3 1 null 1 2 3 1 3 1 null 1. Oh, okay, this is so we should get 2. Oh shit, we get nothing. What's the problem? We here we got leaf node. Check the stack. Oh, so there's no log here? Uh-oh. Where is the problem? Is palindromic? All stack length. I'll say console log. Yeah. There's no log, man. There's no log. Oh, we have a log here. We first push 233 in. And then this is a node, while stack. Then this. Oh, we have a typo. Shit. We got a leaf node, which is stack length -1 is val. Okay. Leaf node 3, leaf node 1, leaf node 1, leaf node 1, leaf node 3, leaf node 1, leaf node 1. Okay, so now log say check the leaf node we got right. We say check is palindromic, count array. Oh, there's a typo here. We got is palindromic, 2, 1. Ah, yeah. Yeah. Oh, I made a mistake here. So there's a 2, 3, but we need to count. The count is not 0, but count of all. Actually, we plus count. If count is 1, we count of 1. Okay. Not 1, but odd count. Count of odd. So if the count is odd, we count up odd plus 1. The other is even, so it's okay. And then we will loop through all of them. And finally, if the total count is even, like 1, 1, 0, 1, then there must be count of R. This must be even. R must be, oh no, it must be count of even. Like 3 numbers. No. I'm confused. So if like 1, 0, 1, 1, 1, 1, 1, 1, 1, 2, 2, 1, 1, 2. There must be only one odd. Yeah. There must be only one odd number, odd count. Yeah. If it is even, then it must be no. So this is cool. This should be right? Run the code. Runtime error. Count of. Let's count. Equal to. I think we're right here. Let's try using sample case. Run the code. Remove the console log. Wow, this is actually not that simple, not that easy. 2 1 1, right? This is 2. This is 1 9 1. Yeah, I think it's right. Okay, the edge case, there will be no empty tree. Let's submit. Wrong answer? For tree like this, expecting 1, but we got 0. 766. Sad. So 766 is actually a good one. Control log leaf. Leaf node is no. And this and the count array. We lock it. We run the code. Okay, we got leaf node 9, which is 111, right? So 1 1. Not a number. What is that? 0 1 2 3 4 5 6 7 8 9. Not a number. For 9 we need is 10. Shit. I made a stupid mistake that yeah, for index 1 to 9 I need to initialize array with 10. Yeah, cool, finally accepted, but penalty time, very sad. Okay, so for this array, try it 3. Wow, people. High acceptance rate. So we have still 40 minutes to the last one, which should be a hard one. Yeah. Max dot product of 2 subsequents given 2 arrays. Return the maximum dot product between non-empty subsequence of nums 1 nums 2 with the same name. What is it? A subsequence of array is a new array which is formed from the original array by deleting some of the characters without disturbing the relevant positions of the remaining characters. This is subsequence of this. Well, okay, order is kept. Cool. So like this, take subsequence 2 minus 2 and from num1 subsequent 3, this from nums 2, their dot is 18. So this 3 7 21. So the basic form, if we're going to say there's only one, pick one number in this, we could just look through each of the pairs and get the result, right? Like 3 5, I think is the biggest one. Now if we're going to get two numbers, like we're getting like this. Before we got 3, so we choose the biggest one. We use linear time, and now we have 0 in. If we're going to use 0, what's it gonna be? Well, it's the sum of the array, right? So the sum of 3 plus sum 1 is already calculated, and now we calculated 0 times sum 1. So because we need to keep the order, if 3 picks a number like here, so 0 must be pick the previous one, like 5, right? The one after that. So that become for A. So actually we need to keep the starting index, like say for 3. For 3 there's a range, right? So suppose how to say 3 0 must be start from this. Start from 0. Okay. So if we say a I j equals nums 1 I dot dot dot, the biggest one, max, right? Max. Now until, right? We start from the until. So until I max nums 2 j. This for j, we have this max. For 3, max at 2 or max 3, we could get it. And then if we have a 0, now we need to, okay, reverse one. We need to get it backward, right? For 0, we need to go backward and check which one is bigger. But if the k, what's the name k? The k would be, oh, there's no limitation of k. If there's the next one, 6, it would be like 3, 6. I'm doing a check. Okay, I'm confused. Let's suppose how many combinations are there, right? So what we're gonna do is first we pick one number, and there will be like n, right? And then the 2 number, for 2 numbers we'll pick 2 and pick 2 here and calculate the sum and get the maximum. Wow, that is very big. So C M 2 numbers here and 2 numbers here, right? So times C N 2, which is big. 3 numbers. Wow, it's C M 3 times C N 3. Wow, it's super big. And so we need to cache, as we analyzed before. If we get the 1 number problem, when we're getting 2 number problem, actually we could pick this number, pick the index, and then get the maximum backward, right? For 0. Okay, now how about 6? Well, suppose 3, 0 is already done. If 3 is in it or not. If 3 is in it, then the biggest one. Huh? Wait a second. So suppose the final best array, the combination is set, and we determine if 6 is in it or not. If 6 is in it, then it must 6 would choose some numbers, right? So like suppose as I, because we the order is kept, so this problem becomes 3, 0, and with the subarray from nums here. So it's a sub problem. And if 6 is not in it, then it becomes 3, 0 till here, right? It's still a sub problem. So it's dynamic programming. Finally, I understand what it is. So let's suppose the max ij, it means we can use the array from nums 1 to the index I with nums 2 to the index j. It will actually be equals to, suppose nums 1 is longer. Okay, with 6 not in it, when 6 is not in it, so it should be max I j minus 1, right? It's not in it. And plus, well, it's in it, then it would be it's in it, then it should be max j2 okay, max, we loop through the words backward, so j, oh no, k, I minus 1, okay, I to I to 1, right? Backward, and it will be max I. How can I put this? Okay, put this better. If k is not in, max okay, I use this one, max for k this, and we will calculate it. Max dot means k minus 1, j minus 1, plus what? Plus nums 2 j times nums 1 I, right? Oh, not y, I k minus 1. Oh no, nums k. Oh cool, we get the finally we get the dp function. Okay, so the clear, we need to store the ij, right? Okay, we use a two-dimensional array, which is the dp new, which I can also use cache. No, yeah, the dp new array means 1 equals nums to 1. Actually, it doesn't matter which one. So we'll just use num2. So this one is no longer needed. nums2 done then. db new array nums1. This one. With fill 0 map new array is 2 to fill, because we need to get the max. It might be negative. When we are looped like we get in the first one, it's okay. I'm not here. Yeah. So the math product always k-1, so it should be checked. No problem. We don't need to fill, or we fill. We don't fill. Cool. Yeah, so the B is like this. New array. Now we will start our calculation. The first one, we will do it length by length, right? With 1 digit and then 2 digits and the 3 numbers, something like this. So minimum, mean length, math, mean length. Okay, for while mean length is bigger than 1, mean that length will be like 3. So we got 3, 2, 1. So while it's bigger than 1, it will stop at 0. Length 0. Okay, I just for loop. For that I is 1. Now we need to update the DP array. For I, it will be updating the ith row and the ith column, right? So how can I do it? So for I, if I is 1, we will choose the first one and the second and up get the maximum. Right? 1, 1, 1, 2. Okay, so like we draw a table, and the length is the 1, means it's the 2. Okay, so we for let j length. Okay. I 0 I smaller than, and then it's 1 I plus plus. We update it for I for 1, and then so here should also be 1, right? If 2 for 1, okay, we start using 0. 0 is better. We first update the row, which is for this. Okay, for I equals 0 for each row, like 2, 1, this. And wow, this is confusing. And for j, so I would not actually start from 0. We start from length, right? Because for length of 1, there will not be enough. If it was 1, there will not be enough numbers. So I actually will start with length. Of course, j will start with length also. J is smaller than length 2. J++, which means for 1, we first loop through for each 2, they will be like this, right? So if j equals length, okay? This is hard. So the maximum ij this is not right actually. Length would be, if we pick this as the minimum, if length equals 1, okay, 1. If it's length 1, what we could do is this. If loop through this way. I see. I see. So updated for God. Don't panic. 0, 0, 1, 1, 2, 2. So 0, 0 means with length 1, of course. Oh, I think we don't need to the that thing. We first get the 0, okay, and then we calculate 1, 1. 1, 1, of course, means the maximum of all. Right? If 1 is used, it is used. Yeah, we don't need the length thing, which is stupid. Okay, for let I equals 0, experiment 1 plus 4. J equals 0, j squared minus 2, j plus plus. So if j is 0, for the j is 0, which was 2, we will update the row to, like, update the column, right? So the maximum actually would be Actually, it would be, yeah, 2 with the biggest one. So if j equals 0, then if I is 0 and j is 0, if I is 0, j is 0, then it must be itself. So dp ij equals to nums1 0 times nums2 0. Right? And for the other case, if I is 0, and then it must be if I is 0, then it's the column, right? It's the column, so else if I 0, it's the column, so it's the previous one versus the current one. So dpi no, it's because I 0, so this is I, this is j, so this is the row, not column. Okay, I j equals max dp I j minus 1 versus nums 1 0 times nums 2 j, right? Which means for 2, 6 is bigger, but 0 is also bigger. So yeah. Else if j is 0, then dp, we could do the same, dp ij, which means the column. Okay, so I minus 1 j times, okay, I'll use I here, nums I and j, right? Cool. If all of them are not 0, there's something here, like for 5, 6, well, it says as we said, the biggest sum here should be the biggest sum of previous one. So for the other case, dp ij equals math max dp I minus 1 j the previous one is used. Okay, so I is same, j minus 1. If it means number is not in the final array, which means yk minus 1. Okay. Oh, it is. If not in the unit, it's this. Well, the other case, the maximum would be, okay, so let max if count if used infinity infinity for that k equals what? K equals I to 1. Okay, so if the last one is used for k, which means I, okay, so it's I, k is bigger than 0, k minus 1, max if used equals to math max nums 1k times nums 2i j, yeah, which will plus, right, which will plus dp I minus 1, not I minus 1, but k minus 1, and j minus 1. Yeah, this is the max if used, or if it is not used, then it would be the previous one, right? If not used, we just say it means I the previous one. Yeah, cool. Max if used. I think I've done. Wow. Return. Wow, the end should be dp nums1.length minus 1 nums2 length 1. I don't think I can pass it with one try. Anyway, min length. There's no min length thing. Cannot be a property of 0 of undefined. The case here is j is not 0, so k is k could be this. If it's used, it could be if k is this, then yeah, so yeah, so okay, k is bigger than 0, then it's this. If not, then it's 0. 15. What do we get? 3. We get 18. Let's log the dp. Okay, so we got 666. Okay, wait a minute. 666, which means for the first 0, 2, we get is 6. It's right. And then if we continue here, what we got? If 2, 1, 2, 3, 0. And the biggest one should be, of course, 666. And if there's -2 and -3, should be 18 here. Okay, so there's a problem. 3, 3. Yeah, 3 case is not okay. I mean, the condition here should be okay. 0 is 3. Yeah, 6. Cool. And 2. 6. Yeah, it's cool. And for -2, for 6, if we will loop through actually k here, we times it. Actually, I forgot the previous one. Yeah, damn. Still 15. Max use time. I think I have a problem here. Oh yeah, I think. Oh. Yeah. Oh yeah. Hope it goes well, man. Let's just try. I'm afraid of the sample case. Okay, this 306 is 21. Cool. And then 3 minus 2. What? 3 minus 2. We got -1. K will be subsequence. We got a problem. 3 minus 1. Okay, -1. We were getting it right. Let's submit. Run answer. Of course. We got run answer. Always. Why? Like this? Man, I don't know. Let's try this, a simple case. I think we already get it right. What? For this case, it's not going to work. One-time error. Why there's one-time error? Mission 6. What's the problem? The problem we are doing the check here. Max is used, then yeah, this is right. Max is refused, there's a problem, right? So update it, and the I will actually be from to 0. Cool. Or they might be not used, right? If it is used, then the maximum k times 2 plus, if k is bigger than 0, then this. Actually, this is 0, right? Maximum. No. Actually, we could. Actually, maximum the previous one. Like here, we already checked the 0 case. This is a use case. TPI J will be coming to here. This should be right. This is also right. If k equal to 0, if k equal to 0, then actually it's already be calculated. So it should be bigger than 0. Remove this condition. Is this the problem? It says we there's no yes. Runtime error. I don't know. Submit. No answer for this? What? Yeah, there's something wrong with the LeetCode, I think. Now return the 18. Well, we get 18. What? I cannot delete. 1821. God. Unexpected JSON input. What the fuck is this? Okay, here look at 18. Let's lock the DP. If we go to the previous one, then it is used, then we have the previous before, or there's no previous one, right? So it should be DP DP 0 J. Oh, maybe this is right. Submit. Still right. So it doesn't change the problem. Why? Okay, the time is up. Why? What's the problem? J minus 1. If it is used, then it should be. If you pick someone, then it's this, right? No problem. If it is not used, it might be something like this. So I don't know. Time is up. Allow me. What's the problem for the case of this? You get miss 6. 20, 200. First one is shorter. Maybe copy paste the input. This should be alright, right? Unexpected JSON input. Huh. What the fuck? Anyway, I failed at this one, but I think I'm almost there. This allow me to try 10 more minutes. What's the problem? Is there a logic problem here? Problem is simple. If last word is used, then it must be used to compare some numbers, right? So the I, go to the 0, and then if we sum them up, it will compare the previous one. The maximum, and then we will update the max. So that would be max to this to this. And if then there's another number, it's the same. So I'll try to calculate by myself about the 3. Let's input the log minus 1 equals this, minus 2 equals this. We log the DP, we run code. Okay, so we get something like this. 194. Let's remove the code one by one to see if it's right. Okay, like this, what we get? Okay, we got minus 27. It would be bigger, right? So minus 27, that's 27, 27. So yeah, it's right. And then what? Another digit? Maybe 72 is biggest. Or 72 plus 24. 72 plus 24 is 96. Our code should be based on this 96. 96. 91. So actually we missed something. We missed 90. Wait a minute. The order must be kept, right? So there's 26. 26 and 94. 90. 90. We get 91. Wait a minute. This 27 is this. 27 and 94. And then this is minus 27. Here. Yeah, we should use minus 6. To here, minus 6 to here, 72 should be 66. What is 66? Actually 72, right? So here's a problem actually. This is the problem. If I0, we have, of course, the biggest one is 27. But when we get 8 in, what's the biggest one? The biggest should be, because there's only one negative number, so it's 72. But we got 66. Why we got 66? Because we were checking. Actually, we're checking this, right? Because nums 2. If it is different, the order matters. Doesn't matter. Okay, now. So this one is 26. Okay, now 66. Where is like 66 come from? It means 72 minus 6. As we said before, actually, I see. Actually, we don't need the previous one, right? Max if used this plus 0. Yeah. I see what happens. Oh. There's a case that we don't use them. Just 8 minutes. Huh? Still wrong answer. Oh shit. Is it's used. I see. I see what happened. Infinity. This is this, and max should be. If it's smaller than 0, we could avoid it. We don't use it. This should work. Still, man, give me a break. Ah, God, I forgot this. Shit. Runtime error? Finally, I got it. Man, but just 9 minutes. I finally got it as a newbie programmer. Wow. So let's see what's the score. Yeah, sad. 2012. Yeah, I failed. Like, penalty time is not good. Wow. Not very good, but the good thing is that I tackled these all 4 problems with the extra 10 minutes. I really should handle the edge cases better. Well, I need more practice, so that's all for this live broadcasting. Hope to see you soon. Bye bye.